So this is the practice quiz, which is almost identical to tomorrow's quiz. The only difference is that it's longer, right? This practice quiz is about 26 points. The actual quiz tomorrow is going to be 20. And we are going to have graphing parabolas. Why will it not let me zoom in? Okay, there we go. We are going to have graphing parabolas. You're going to have to graph one like this one. And notice I have a bunch of questions with regards to this parabola. However, you're going to have less questions on tomorrow's quiz with regards to this parabola. I'm going to chop this down by deleting some of these, okay? But we still need to remember how to answer all these questions. So how do we start graphing a parabola? Anybody? Identifying or finding your vertex, right? If it were in vertex form, yeah, H and K. But it's not in vertex form, it's in standard, which means we're going to have to use a formula x equals negative b over 2 times a. So your x value is negative parenthesis over 2 times parenthesis. And of course, the b value is negative 4, the a value is negative 2, and the c value we don't really care about right now. So we put in the negative 4 for b. The a value is negative 2. We will end up with the x value being positive 4 over negative 4, which is really positive 4 over negative 4. That's really going to be a negative 1 for your x value, correct? All right, so our vertex is a coordinate that has the x value of negative 1. Now we still need the y value, so we're going to plug in that negative 1 into the x's of the original equation. So I'm going to rewrite my original equation over here. I give space for work. I would like you to show your work right here. You probably are not going to have enough space. You might have to staple extra scratch paper onto your quiz tomorrow. But anyway, I'm going to plug it in. So I'm going to rewrite my equation. And of course, I put parentheses instead of the x. So I put negative 2 parentheses squared minus 4 parentheses plus 6. There it is. Let's plug in that x value of negative 1 into those parentheses. Let's do the math. Negative 1 squared, that's positive 1. Negative 2 times positive 1, that's negative 2. Negative 4 times negative 1, that's positive 4. Bring down the plus 6. Then just from left to right, combine negative 2 plus 4, that's 2. And 2 plus 6 is 8. So the vertex y value is 8. Again, the y value is 8. Now the vertex, from here on out, everything else is easy because the vertex is your maximum. You could find your axis of symmetry right through that vertex. The range, it's going to be depending on if it opens up or down, but you're going to use the vertex. So all of these questions are very easily answered by understanding the vertex. But let's graph our parabola right now. We're going to begin by going to the coordinate negative 1, positive 8, which is up here. We're going to draw the axis of symmetry right through it. And from that point, we need to use a pattern. Could we use the pattern 1, 1, 2, 4, 3, 9? No, the a value is negative 2. So that changes everything, okay? So right here, I want to write my pattern of 1, 1, 2, 4, 3, 9. 1, 1, 2, 4, 3, 9. But I can't use that pattern because this pattern belongs to any quadratic function that has an a value of 1. But we know that this a value is actually what? Negative 2, right? You could see the a value up here. It's negative 2. So what we need to do is modify the outputs of the pattern by this new a value. Now the negative, all that you care about with regards to the negative is that it's opening down. So you don't even have to put that negative. You could just scratch it out and just say that your a value is 2. So let's modify the outputs by that new a value of 2, thus giving us our new outputs. 1 times 2 is 2, 4 times 2 is 8, 9 times 2 is 18. So the new pattern, based off of this new a value of 2, is 1, 2, 2, 8, 3, 18. And once again, the negative, all it tells you is that it's opening down. I know this is review from the last chapter, but we can't forget about parabolas. It's all over the final exam. So let's go to our vertex, and let's go 1 over 2 down. Instead of 1, 1, it's 1, 2 down. Let's put a dot right there. Let's go back to the vertex. Let's go 2 over 8 down. So 8 down will take us back to the x-axis, actually. Let's put a dot right there. And last but not least, 3 over. Most of the time we're not going to be able to apply this one, But this one, I think it'll fit. 3 over 1, 2, 3, and then 18 down. Well, here's 8, and 10 more will take you right to the edge right there. So you are able to actually graph this one. And of course, the axis symmetry allows you to map it over to reflect it over to the other side. And you just draw your parabola right through those points. So notice I didn't go all the way. If you want to, go ahead. You could actually draw it all the way to these points, or you could just put arrows on it and make sure that they're pointing towards those points. It's up to you. Okay, anyway, so we graphed it. That's a point. What else could we say? Well, we could already state the axis of symmetry. The axis of symmetry is simply x equals the x value of your vertex, which is -1. What pattern did we use? We already said it was 1, 2, 2, 4, 3, 18. State the max or min value. Well, because the a value, because it's opening down, that is a maximum height, right? You throw something up in the air, it reaches a maximum height, then it comes back down. What is that maximum height? That's the y value of your vertex. So you would say that your max value is at 8, at y equals 8, right? State the y-intercepts. Well, you could clearly see that it crosses right here, and if you count where that location's at, that would be 6. Okay, so the y-intercept is at 6. Let's say you didn't see the graph, you could simply plug in 0. To find your y-intercept, you set x equal to 0, and your c value will be your answer, which is that same 6. State the x-intercepts. Well, how do you find the x-intercepts? You set y equal to 0 and solve, which means you have to use the quadratic formula or factor split and solve. But since we already have it graphed, all you have to do is see where they cross the x-axis. So it crosses right here at 1 and also at -1, 2, 3. So 1, -3 would be your answers there. 1 and -3. State the domain and range. We should all know that the domain is x equals all real numbers. You don't even need the vertex for that. But you do know that the range is y is either above the max value or below that max value or min value. So right here, it's a max, which means the whole thing is below it. So how do we say that this whole parabola is at 8 or below? Y is less than or equal to 8. Perfect. Rewrite the equation in vertex form. Well, if you know your vertex, that's technically an h and k value. That's your h and that's your k. And all you need is an a, right? Remember, all you need to write an equation in vertex form is the a, the h, and the k. Now, we already know the a. The a is -2, so let's start writing it out. First of all, what is vertex form? It's y equals a, parentheses x minus h squared plus k. So our answer will be y equals a, which is -2, open parenthesis, x minus h, and h happens to be a -1, close parenthesis, squared plus k, which is plus 8. So the only other thing you could do is change the minus to plus. There's your vertex form equation. It's right here. It's a lot. I apologize. I will chop it down and not ask that many questions about this. Okay, so that's the first part. I'm going to chop it down to maybe like 4 points, not 9 points. That's ridiculous, right? I'm going to chop it down like 4 or 5 points tops. And then we're going to have some simplifying. Simplifying's cake. Why is it cake? Well, if you're adding, all you're doing, when you're adding one polynomial with a number, with another polynomial, all you're doing is combining like terms. So let's go with the highest exponent first. Let's combine -2f to the second with -2f to the second. You're combining. If you owe $2 and you owe $2, you're going to owe 4 of those specific dollars. Notice f squared stays, right? Now, let's go on to the f's. We have -3f and another -3f. Well, you owe 3, you're going to owe 6 of those f's. And last but not least, you owe 5, you have 8, you're going to have 3 left over. We are done. That's like the easiest type of question I could ask, right? Maybe I don't ask it. It's too easy. Number 11, that one's just as easy, but there's a minus sign. So you can't just start combining. You have to distribute that minus sign to each of the terms. So you have 5d plus 5 minus d minus 1, and then you combine like terms. The 5d with the minus d, that's 4d. And then we're going to combine the 5 with the minus 1, which gives us a positive 4. There's your answer, 4d plus 4. Here we go. Number 12. A lot of people mess up on this one. A lot of people mess up on this one. A lot of people want to apply that rule of exponents that says that if you have parentheses with the exponent on the outside, you distribute it in. That only works if you have a monomial. But right here, it's a binomial. There's a minus sign separating the 2a with the 5, so you cannot distribute that 2. Do not do that. What we have to do here is take this binomial, the base, which is a binomial, and multiply it with itself 2 times. So let's do exactly that. Once you write it, you'll be like, oh, this is an easy problem. Right? 2a minus 5 times 2a minus 5, just distribute 2a times 2a. 4a squared, 2a times minus 5, that's minus 10a. Then distribute the minus 5 times 2a, that's a minus 10a again, and minus 5 times minus 5 is plus 25. Of course, we're going to combine the middle terms. Negative 10a and negative 10a is negative 20 of those a's. Bring down the 4a squared, bring down the plus 25. There's your answer for number 12. Yay? Yay. Okay. Same thing with number 13. Distribute 3y times 2y, that's 6 with a y squared. 3y times negative 3, that's negative 9y. And then positive 4 times 2y, that's positive 8y. Positive 4 times negative 3 is negative 12. Of course, combine the middle terms, the negative 9y with the positive 8y, that's simply a negative 1 of those y's. Bring down the 6y squared, the minus 12, and that's your answer for number 13. This one's fun. I like these. Why? Because we just cancel a bunch of things out, right? When we take a look at the fraction negative 3 over 18, you could reduce the negative 3 and the 18, right? 18 divided by 3 is 6. But there's going to be a 6 left over on the bottom, not on the top. If the 18 were on top, yeah, it'd be left over up on top. But it's on the bottom, so you have a 6 left over on the bottom. What about the n's? Well, you have one n on the bottom. That one single n will completely cancel with one of these 7, and you're going to have 6 left over up on top. You have 4 x's up on top. All 4 x's completely cancel out with 4 of the 7, which means I'll have 3 left over on the bottom. So what's my answer? I have a fraction. It has a negative sign up on top. It does have an n to the 6th also left over up on top. And on the bottom we have a 6, an x, and a third power. That's your answer for number 15. Easy peasy lemon squeezy. Yeah. Simple as popping a pimple in a dimple. That is disgusting. I apologize. Pimple in a dimple. Yes. What is anything to the 0 power? 1. 1. So this b to the 0, you could just cancel it out. Why is that? Why could you cancel it? Because anything times 1, I mean, if I put multiply by 1, it's not going to change anything, right? Yep. So you could just scratch it out. Don't even worry about it. It's gone. Anything to the 0 power is gone. What's left? Well, there's 2 things you could do. You could either apply the rule of exponents that have negative exponents, which means you have to move down to the denominator or move up if it's at the bottom. Or you could use rule 1, which is if you're multiplying 2 terms with the same base, you could add the exponents. So it's up to you. You're going to have to apply both rules anyway. Which one do you want to go with first? First rule? Okay, let's combine. If you have the same base and you're multiplying, go ahead and combine that with that and put it over that base. So it's a to the negative 9. Okay? And now after that, you have to deal with the rule of negative exponents. You have to take this whole term and move it down below to the denominator. What denominator? It's not a fraction. Yeah, we're going to make it a fraction. So you're going to move it down. So what's left over up on top? Nothing. So you put a 1 up there. You don't put a 0. You put a 1 if there's nothing left over. And of course, that a to the negative 9 moves down and it becomes a to the positive 9. Let's move on to the next question. 17. It could be tricky. What's the answer? Anybody? Is it 1 over 2x to the third?
2 over x to the third.
It's 2 over x to the third. Good job. Didn't trick anybody. You take that value that has a negative exponent, you move it down to the other side, make it a fraction. So the 2 does not have a negative exponent. The 2 is going to stay right up there. The x to the negative third moves down and it becomes x to the positive third. There's your answer. Did I say turd? I'm sorry. Number 18. I skipped one. 14. Okay. Trying to avoid that one. No, I'm just kidding. I just totally skipped it. I'm sorry. Okay, so right here we are going to apply that rule that if you have parentheses with the exponent on the outside, you distribute it into each term only when you have a monomial. Notice that this is not a binomial. It doesn't say 2 plus f to the third. It doesn't say 2 minus f to the third. If you have a bunch of multiplication or division, you're going to distribute that exponent to each exponent on the inside. And remember that a power to a power, you multiply. So there's really a 1 right here. I'm going to go 5 times 1, and I'm going to get 2 to the 5th. I'm going to go 5 times 3, and I'm going to get f to the 15th. Now that's your answer. However, if you could actually do 2 to the 5th, please do so. So on the quiz tomorrow, I don't want to see 2 to the 5th. I want to see 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32. So I want to see 32 f to the 15th as your final answer on number 14. Of course, you could use calculators, so don't sweat that. Moving on, down here, we're finally getting to dividing a polynomial by a monomial. And that was one of the topics that we covered on yesterday's lesson. What do we do when we have a monomial divided by when we have a polynomial divided by a monomial? What do? You split them up. You don't use long division. You could, but that'd be a nightmare, right, on certain questions. So it's easier to just separate the denominator to each of those terms. So let's do exactly that. We're going to have a 15r to the 10th over that denominator 5r to the 4th. And then we have a minus 5r to the 8th over 5r to the 4th, and then plus 40r to the 2nd over 5r to the 4th. So all I did was take this single denominator and put it underneath each and every one. And now we could look at these as 3 simplifying fractions problems, which is just reducing, canceling, right? So on this first fraction, I could cancel out the 15 and the 5. What's 15 divided by 5? 3, and of course that 3 is going to go up on top because the bigger value 15 was up on top. I do have 4 r's on the bottom, 10 r's on top. 4 of these r's completely cancel with 4 of the 10, which means I have 6 left over up on top. So the first part of my answer is 3r to the 6th, no more fraction. I could put it over 1, but there's no point in that. Let's move on to the second fraction. The 5 divided by 5 completely cancel. 4 r's on the bottom cancel with 4 of these 8. You're going to have 4 left over up on top. So the next term is no longer a fraction. It's simply a minus r to the 4th. And finally, last but not least, 40 divided by 5 is 8. 2 r's on top cancel with 2 of these. You're going to have 2 left over. So your final fraction here is a plus 8 over r squared. Ladies and gentlemen, this is your answer for that problem. So dividing a polynomial by a monomial is pretty easy. All you have to do is split it up. Number 19, it's the same exact thing. It's a polynomial divided by a monomial. It looks like we're multiplying, but we're not multiplying. Remember the rule of exponent that has a negative exponent. You grab it, move it to the other side, it becomes positive. So you really have this large polynomial divided by 4dk squared to the power of 1. Positive 1, so you don't need that power of positive 1, so I'm just going to erase it and leave it as 4dk squared. And again, we're going to split that up to each of the terms. So I'm going to put the 4dk squared underneath this first one, underneath the second one, and underneath that third one. So there's the setup, and of course we just simplify after that. 28 divided by 4 is 7. There's going to be a coefficient of 7 up on top on the numerator. There's 1d on the bottom, which cancels with 1 of the 3, which means there's 2 left over up on top. Both k's that are up on top cancel with both k's on the bottom. There are no more k's. So the first term is 7d to the 2nd power. The middle fraction, there's a 4 down here, but there's no number up here, so you can't do anything with that 4. But there are d's that we could cancel. There's 1d cancels with 1d. There's going to be 1 left over up on top. Both k's with both k's. The second or the middle term will be a fraction plus d to the 1 over 4. So you could just put d over 4. Another detail, guys, you could rewrite this as 1/4 with the d on the side. 1/4 with the d on the side. I'm going to leave it like that, though. That's a perfectly fine answer. Last but not least, notice that we have the same identical 4dk squared over 4dk squared. The identical values both on top and bottom. That means that those completely cancel. You have a negative 1 left over at the very end. So there's your answer for number 19. Let's take a look at number 20. On this back side, we are dividing a polynomial by a binomial, and it's a nice, simple, pretty binomial, right? So if it's a nice, easy binomial like this, do synthetic division. So inside the box, you do a reverse L. Inside that box, you put the opposite value of your constant of the binomial that you're dividing by. You put the opposite value of the constant of the binomial that you're dividing by. So you're going to put a -3 inside the box. And then you want a list of your coefficients. You got to represent every single term, every single power. So you have x to the third. Notice that there is no x squared. So, I mean, if you wanted to, right off the bat, since there's no x squared, you could put a plus 0x squared right here, because you're going to have to fill in that spot with a 0. Whether you're doing long division or synthetic, you have to fill in that spot with a 0. So the first coefficient is 2. The next one will be a 0. The next one will be a 4. And the final one will be a -6. And you're going to draw your line, but don't do the line too close to the numbers, because we're going to be writing numbers right there between the numbers and the line. So as you go down, you combine. 2 plus nothing is 2. As you go up, you multiply. -3 times 2 is -6. As you go down, you combine. 0 and -6 is -6. As you go up, you multiply. -3 times -6 is +18. As you go down, you combine. 4 plus 18, 22. As you go up, you multiply. -3 times 22 is -66. Now, at this point, I am going to put a line right here, and whatever I get at the very end, that's my remainder. So the -6 with the -66, that is a -72, and that is my remainder. So this is technically our answer. All we have to do is put our variables into this answer. These are the coefficients. If you did start with the x to the third, and of course you divided by a single x, what's your new power going to be? X squared, right? So your answer is 2x squared minus 6 of those x's, and then the 22, the positive 22 is the constant. Ladies and gentlemen, this number right before this line right here, it's always going to be the constant, just like this number over here is always going to be the remainder. So how do we do a remainder? You simply add or subtract it, but you put it over the original divisor. So this is a -72. I'm going to put a minus, and I want to put that 72 on top of the original binomial that we're dividing by, which is a x plus 3. So there's my final full correct answer. Everybody's on their way to an A+. Let's move on to the next one. Notice that these are worth 2 points each. All right, so this is another synthetic division problem. It looks like you're multiplying, but because of that negative exponent, remember negative exponents mean you move them to the other side. So I would actually have to take this x plus 2 to the -1, move it down. So I have this polynomial divided by x plus 2 to the 1 power, and it becomes positive instead of negative. But then again, you're not going to write the power of 1, and you're not even going to put the parentheses. It's this simple. You have a polynomial divided by a nice binomial. So you're just going to use synthetic division again. Put the box like that. What goes inside the box? -2. Thank you, -2. Now what's my list of coefficients? 1, -3, 0. There is no x squared. And then? 5. +5, -6 at the very end. Draw your line. Well, that's an ugly line. I'm sorry. As you go down, you combine. 1 plus nothing is 1. As you go up, -2 times 1, that gives me a -2. As you go down, you combine. -3 combined with -2 is? -5. As you go up, -2 times -5 is? +10. As you go down, combine. 0 combined with 10 is? 10. As you go up, multiply. -2 times 10 is? -20. As you go down, you combine. 5 and -20 is -15. As you go up, you multiply. -2 times -15 is +30. Again, put this line right here. Anything after that line, that last number you're getting, that's the remainder, which happens to be a +24. So our answer, since we started with the x to the fourth and we're dividing by 1x, the new power should be what on the first term? X to the third, 1x to the third. So you could put the 1 in front of the x to the third. I normally don't. You don't need the 1. And then move on to the next one. That's a -5, so it'd have to be an x to the second, plus 10, that has to be an x, Again, this number here is always going to be the constant, which is a number without the variable. And the plus 24, that means that you're going to put plus, you're going to make a fraction. That 24 is the remainder. You put that remainder over the original divisor, x plus 2, that binomial. So there's your final answer for that one. It's 2 points each. Here's another 2-pointer. Same exact thing. What goes inside of the box? -2. And how about that list of coefficients? Well, yeah, we're going to start with 6, but could somebody tell me all of them? 6, what else? 15. -8. 0 because there's no y. -6 at the very end. Put your line right there. As you go down, combine 6 plus nothing. There's nothing there. That's just 6. -2 times 6 is -12. Positive 15 combined with -12. What do I get? 3. When I multiply -2 times 3, what do I get? -6. When I combine -8 and -6, what do I get? -14. When I multiply -2 times -14, what do I get? Positive 28. When I combine 0 with 28, what do I get? 28. When you multiply -2 times 28, what do I get? And of course, this is my last one, so that's going to be my remainder. What's my remainder? -62. So again, my answer, since I started originally with the 6y to the 4th, I had a power of 4, and I'm dividing by 1y, that's going to drop it to the power of 3. So this first term will be with the power of 3. So that's going to be 6y to the power of 3 plus 3y to the power of 2 minus 14y plus 28, and then minus, and you put a fraction with your original, with your remainder, 62, over the original denominator y plus 2. Original divisor y plus 2. Now notice that it was a -62, and that's why I put a minus out here in the front. Don't put a minus out in front and a minus up there. That'd be incorrect. That would mean positive. So that minus, I simply put it out here in front, and there's my final correct answer. Again, this practice quiz is longer than the actual quiz tomorrow. We're not going to have this many questions, but they will be worth 2 points each. Especially this last one. Man, this last one's definitely a handful. Now, why is it a handful? Because the binomial is not a nice binomial. You see, you could use synthetic, but inside the box, you'd actually have to plug in the fraction 3/2, and that would be disgusting to be multiplying and adding and subtracting fractions, right? So let's not even go there. Let's just set up our long division problem. So the polynomial goes inside the box, and notice there's no powers missing. 3, 2, 1, constant, perfect. All right, so now this divisor, this binomial, it's not that nice. We're going to put it out here. We're dividing by that binomial, 2r minus 3. And again, just like long division in the 5th grade, you don't think of like 8,557 divided by 21. You don't think of the whole thing. You just look at the first number 8 and the first number 2. In this case, you're going to look at the first term, 2r to the 3rd, and look at 2r and think 2r times what will get you that 2r to the 3rd? R squared. Now you're going to put that r squared right on top of the other r squares. That's how you stay organized. And then it's just a distribution problem, right? R squared times 2r, that's 2r to the 3rd. Write that down right here, 2r to the 3rd. And then r squared times -3, that's a -3r squared. Now we are subtracting, so put parentheses around it with the minus sign out in front. That means that you need to distribute it to both terms. If you don't distribute, everything's going to be wrong. Okay, so when you distribute it, you have a -2 right here. It'll cancel out. This will be a +3. 5 plus 3 is 8. So I end up with a +8 of these r squares. And then I simply bring down the next value, the next term, -2r. And then again, you focus just on the first term. 2r times what will get us that 8r squared? 2r times +4r. That'll get you that first term, 8r squared. And then 4r, when you distribute it to the -3, that'll be -12 with an r. And of course, we are subtracting, so you put the subtraction bar, the parentheses, the minus, and you distribute, right? This one right here will cancel out, but this one over here will become positive, which means that you have negative 2 plus 10 of those r's, so you will have 10 r's. Bring down the minus 15 at the very end. Final thing to think of is 2r times what gets us that exact 10r? That will be a 5, right? 2r times 5 will give you that exact 10r value. And then 5 times negative 3, when you distribute, will give you negative 15. So there's some niceness to this disgusting problem. What is the niceness? That when you subtract, there is no remainder. So you don't have to worry about putting a fraction at the end of this answer. This is your answer, r to the second plus 4r plus 5. We are done with the back side. Please study this entire study practice quiz. I will shorten it though, okay?